The New Journal of Medicine states during a study on factors of falling that out of 306 subjects that are 75 years old or above, 108 of them, which amounts up to 32%, fell at least once during a 1 year follow-up period. 24% of those who fell suffered serious injuries, and 6% had fractures. This shows the severity of elderly people aged 75 or above falling.
To address this critical challenge, our team, comprising of Wei-Kai-Min, Kuai-Chen, and Yi-Mong-Zihai, developed a semi-automated falling evaluation system, S.AF.E, designed to enhance emergency response time. The system autonomously detects fall events and immediately triggers medkit bot, which drives along the preset path to the room where the emergency occurred. This ensures immediate awareness, enabling bystanders intervention and rapid medical assistance.
The system is divided into two phases. The first phase is the detection phase, which in this project we are using HCSR04 ultrasonic sensor mounted on the server motor, which will sweep across the room and constantly monitor the object's height. If the object is detected below the preset line, the system will classify it as fall, which will trigger the second phase, which is the reaction phase. In the reaction phase, the robot will be deployed after receiving the wireless signal from the detection system along a preset path. A button is also mounted on the robot, which is used to command the robot to return its base after a rescue is carried out.
The primary reason we made this project is to eliminate critical response delays during medical emergencies, preserving the golden time for rescue. In standard emergency scenarios, caregivers often lose a lot of time having to locate, retrieve, and transport the medical supplies before reaching the victim. We developed project S.AF.E SAFE to specifically solve this bottleneck by allowing the person in charge to rush directly to the injured person while the medkit bot autonomously delivers all the required first aid equipment to the scene. This project also aligned with Sustainable Development Goals (SDG 3), good health and well-being for drastically reduce response latency to minimize severe post-fall complications and improve survival rates among elderly, and SDG 9, Industry, Innovation and Infrastructure, for demonstrating the practical integration of IoT, radar, sensing and autonomous robotics in modern healthcare environments. The difficulty we face is establishing reliable connection between the newer ESP32 and the older ESP8266 for the overhead radar system to communicate with the medkit bot when it's needed to be deployed. Due to architectural differences between the two generations, such as the differing Wi-Fi structure, API signatures, and channel synchronization protocols, initial data transmission attempts failed to establish a stable connection. We conducted in-depth technical research across various online engineering tutorials, and fortunately, we managed to establish a seamless low-latency wireless bridge between the two boards. If we have more time, we would like to implement AI for enhancing the system. For example, a better and more accurate fall detection system, or AI mapping for the medkit robot.